my YouTube channel. In today's video, we are going to solve problem number 3310, that is removal method from projects. So we are maintaining a project where there are n methods which are numbered from 0 to n minus 1. And we are given two integers, that is n and k, and the integer array which is called as invocations. Invocation, it means some interruptions that has a1 and bi. That indicates the method a1 invokes method b1. Okay. This is known as there is a known bug in method K. Method K along with any method invoked by it, either directly or indirectly, are considered suspicious and we aim to remove them. A group of method can only be removed if no method outside the group invokes any method within it. Okay, so we have to return an array containing all the remaining methods after removing all the suspicious methods. We can return the answer in any order, and if it is not possible to remove all the suspicious, we have to return none. And the none should be removed and we have to return the array itself. Okay, so this was the basic uh, question, detail about the question. Okay, so in this graph, as you can see that we are given with n equal to 4. It means that we have 4 nodes, and with 4 nodes, our infected, or we can say the suspicious node is 1. So you can see that this node is suspicious for us. And this is given as the invocation. Invocation means that one, this is the 1. So 1 is actually dependent on the 2, 0 is dependent on the 1, and 3 is dependent on the 2. So this is the suspicious, and we have to return the array which does not contain any suspicious uh, if it is dependent on it. Suppose if it is suspicious, then due to this node will also get suspicious. But as you can see that if I removed both these processes, the 0 and 3 will become invalid. We cannot remove we cannot remove if a non-suspicious, or we can say if there is a node which is safe, and if there is some another node which is suspicious. If a safe node is dependent on the suspicious node, we cannot remove it. Okay, so as you can see that this is a safe node, but it depends on a suspicious node, so we cannot remove 0 and 1. You can see here 3 is safe node and 2 is suspicious node, so we cannot remove it also. So eventually we cannot remove anything. So we have to return 0, 1, 2, and 3. Okay, so this was the explanation. And okay, so as you can see in this problem, uh, our k equal to 0. It means that our this node is suspicious. Due to this suspicious nature, 0, 1, and 2, this also gets suspicious. But as you can see that this is a non-suspicious and this is also non-suspicious. I can say that it is safe and this is safe also. Both the nodes are safe. If both the nodes are safe and they are not dependent on any other suspicious nodes, so it is very easy that we can remove everything and just we have to return the 3 and 4. As you can see, we have returned 3 and 4 here. So what is the basic approach that we have to think of? So the first approach that we can think is very basic. Like it is about the BFS. You can do any traversal, either it can be a BFS or DFS. Let me start with doing a DFS approach. So if I'm given this array and the suspicion node is 1. If it is suspicious, then I will start a BFS traversal. I will check how many actual nodes are being infected from this node. As you can see that from this one node, my 2 is also being infected. After finding the infected, I can maintain a hash set in which I will just have the number of infected nodes. So as you can see that I have 1 and 2 as my infected node. After finding the infected node, just we have to check whether the safe node is dependent on this infected node or not. If a safe node is dependent on um, any of the infected node, we just have to return the complete array without any changes, because we cannot delete anything. Because however, it is a suspicious node, but we cannot delete it because a safe node is completely dependent on it. So we have to think wisely. Okay, so instead of deleting the complete 1 and 2, and I cannot return 0 and 3, I have to maintain 0, 1, 2, and 3, because they all are dependent on each other. So uh, if there is some dependency, I'm going to return the complete array. And if there is no dependency, then I will just remove this buggy nodes, or I can say the nodes that is involved in the bug, and just have to return the and just return that hash. So let us try run the code. First of all, this line I am just creating an adjacent list. This is the adjacency list. Okay. After doing the adjacency list, I'm just starting from the k. K is our infected node. I will just start my iteration, my BFS from the infected node. After finding the infected node, just I have to check. I have to visit. If it is not visited, then I will just push into the element and I will just insert in the buggy. This buggy hashtag will have some nodes that are actually containing some infectious node that is actually containing some bugs. Okay, so this is the way. This is the way by which we can find the buggy nodes. After finding the buggy nodes, I have to just use a two for loop. The first for loop will actually do when the first for loop will check either a buggy if our I will check if any node is a buggy node and if it depends on anything. You can see that if it is the node and if this node is dependent on a buggy node, then I just have to return the all methods. That is, we I have to return everything from everything of the array. And if I successfully pass this loop, it means that the buggy nodes does not have any element that is present in the buggy but not in the safe. So you can think of like this, like I just have two things that is called as safe and that is called as buggy. Thus, there should not be any relation between the safe and buggy. If there is any relation between the safe and buggy nodes, just I have to return the array itself. And if there is no relation, just I have to return the safe nodes. So this will just check whether there is a relation between the safe node and the buggy node. And this will check this will just return the buggy nodes, safe nodes. Okay. If it is not present in the buggy, then it will obviously in the safe. Then I will just return the answer. This was the code for today's problem of the day. Okay, so let us submit this code. So as you can see, we have solved this problem. Let us discuss the time complexity and the space complexity. The time complexity of this problem will be we are doing a BFS traversal, which is like big of V plus E, and we are doing an iteration for the loops that will be take another time complexity of big of V. So overall time complexity will be big of V plus E, and the space complexity will also be big of V because we are going to use some n number of nodes. Thank you.